Well, good day and welcome to another session of Mathematical Literacy. For those of you who've seen me on TV before will know I'm absolutely passionate about my subject, about mathematical literacy. Why? Because it's all about dealing with real life problems. In fact, today's session is entitled Solving Real World Problems. We're going to get on with our very first question. So here is an example of information given to consumers about electricity costs for households in a city in South Africa. The amount of electricity used is given as a number of units. Right? Here are the two rates. Domestic rate 1, 33.28 cents per unit. A service charge of R1.46 per day applies whether electricity is consumed or not. Domestic rate 2, 45.99 cents per unit. Would ideally be used if your consumption is below 400 units per month. The service charge is not applicable to this rate. Okay, let's have a look at this question. The outline of it is simple. It's saying, you use electricity at home. We're going to charge you for that electricity. Okay? And by we, I mean Eskom. So Eskom have electricity, they're giving it to you, but they're saying, oi, because you're using our product, we're going to charge you for it. And there are two methods of charging you for it. The first method is we're going to charge you a once-off rate. Every day that you use our electricity, we are going to charge you R1.46. So I start my day and Eskom gives me a bill of R1.46. I go to bed at night, wake up the next morning, and I have a charge of R1.46. Go to bed, wake up, R1.46. Go to bed, wake up, R1.46. And I do that every day of the month, before I've even used any electricity. So over and above the service charge of R1.46 every day, Eskom is also going to charge me 33.28 cents per unit. Let's look at it here. They say there's a service charge of R1.46, and then they say also added to that we're going to charge you 33.28 cents per unit. Now I want to stop for a minute and just bring this to your attention because it came up a year or two ago in a final matric paper where so many people read 33.28 cents and say, 0.28? That must mean it's 33.28 rand. But it's not, and don't fall for that. It's 33.28 cents. Now, very seldom do we work with comma of a cent. Where we do use it is when we're dealing with cell phone rates or telephone rates, when we're dealing with electricity rates, and you know we also use comma of a cent when we look at exchange rates as well. So a cent can be part of a cent. So don't forget that. So if I tell you it's 33.28 cents, I don't mean 33.28 rand. It is referring to cents. Right, domestic rate number 2 says this. So one rate, we charge you R1.46 plus 33.28 cents a day. The other rate says, you know what, we're not going to charge you anything per day. But what we are going to do is we are going to charge you 45.99 cents per unit of electricity that you use. Let's have a look at it here. So it's 45.99 cents per unit, but no daily charge. But let's have a look. Here we have a daily charge, but our cost per unit is a lot less. In rate 2, there's no charge, but our rate per unit is a lot higher. So in the one way, we're thinking, gee, I'm doing quite well. I'm not being charged a daily rate. I think I'll go use rate number 1, okay? Or rate number 2, because there's no daily charge. But beware, there's a little trick. And be aware of this in business. There's no such thing as something free. Our first question, if a household used 380 units of electricity in a month and they were charged using domestic rate 1, what would they have to pay for electricity in rands for that month? Okay, so let's look at rate number 1. Rate number 1 said, we are charging you, there it is, 1 rand 46 a day. So in 1 month, let's look at this. 1 month, and there's a very important thing we've got to know here. A month has 31 days in it. Okay, we're going to consider a month of 31 days. Now, it's important that the examiner tells us that, because as you know, a month could have 28 days, February, could have 29 days, February, on a leap year. It could have 30 days, or it could have 31 days. So 31 days in a month. The examiner is telling us that to put our mind at ease, and so we know that every month we're using 31 days. What's the cost going to be? So I've got 31 days. My cost, 31 days, and on each of those days I'm paying an amount of 1 rand 46. So times 1 rand 46. But I have also used 380 units worth of electricity. So they've got to charge me for that, 380 units. How much are they charging me for that? Well, they are charging me 45,9, no, I lie, that's you, rate 2. They are charging me 33,28 cents. So 33,28. Now, I have a huge problem with what I've just written down. Let's look at the board and see if you can work it out. Look here. Let me go to a pink color. Pink reminds me of a woman, and a woman will always find your fault, so we'll use pink. 1 rand 46, 33,28. This is rands and this is cents. Guys, we can't work one part in rands and the other part in cents. Thou shalt not do. Jy moet dit nie doen nie. What? All right. So we've got to change that 33,28 cents into rands. How are we going to do it? Let's divide by 100. Why are we going to divide by 100? We're dividing by 100 because there are 100 cents in a rand. So I'm going to say this is 31 multiplied by 1 rand 46 plus 380 units times, now 33,28 cents divided by 100, we're going to get 0.3328 cents. Now guys, as we mentioned before, to get 3328 cents, that just makes no sense. But we are going to actually break those cents into tiny little bits, multiplied by a big number, so we're allowed to use those tiny little bits. Okay? So let's carry on here. So we got to take out our little calculator, and we're going to say I've got 31 multiplied by 1.46, and I'm getting an answer then of 45 rand 26 cents. So 45 rand 26 cents plus, let's work this out now. Now we have quite a lot of numbers here. We got, let's clear that, 0.3328 multiplied by, okay, 380. 380 units, and we're going to get an answer of 126 rand, 46. Okay, I'm now going to round this off. So we're going to say I've got 126 rand, comma, what did we have? 46. Happy? All we got to do now is add up the two together. So let's do that. So clearing that, we're going to say, cool, 45 rand 0.26 plus the 126.46 126.46. And that gives me a great total of 171 Rand 72. 171 Rand 72 cents. So you using option rate number 1, we're going to pay out 171 Rand 72 cents. I bet I can tell you what the next question's going to be. Let's have a look. The next question's going to be, if a household used 380 units using domestic rate 2, what would they have to pay? Now that was quite obvious they were going to ask that question. The first question, how much are you going to pay to use rate 1? Now, how much are you going to use to pay rate 2? So let's go for it. Okay, so we're going to say, right, our cost here is going to be 380 units. Multiply that by, and how much are they charging us? 45.99 cents. Now, 45.99 cents. Guys, we don't want this. Why? Because it's in cents. Let's change it to rands. How do we get it to rands? We divide by 100. So I'm going to get 0.4599. So 380 multiplied by, no rands, 45.99 cents. And again, simple little calculation. Clear our calculator. 0.4, let's check, 599. Multiply that by 380, and we get an answer of 174 Rand 76. So 174 Rand 76, was it? Yeah, 76. Which was better? Let's go back to our previous page. 171 Rand 72 or 174 Rand. In this case, guys, it was better to use rate number 1, wasn't it? But at some stage, it's going to be better to use rate 2, right? At what stage? And I bet that question's coming up. Let's have a look at our next question. It says, write an equation that relates the monthly payment in rands, important thing that, in rands, for electricity to the number of units of electricity consumed. Okay, so what is our cost going to be? Right, so P is going to be domestic rate 1. What did we say? We said, first of all, it's going to cost us 1 Rand 46. So we've got 1 Rand 46. This is for a month, so it's times 31. Remember, why is it times 31? Because our examiner put our mind at ease and said, oh, you use 31 days in a month. And that's what we're going to do. Plus, there was another cost, and what was the cost? It was 33.28 cents. But remember, this question said, I want the answer in rands. So we're going to take this 33.28 and we're going to change it straight away to rands. So we're going to say this thing here, cross it out. Let's make it 0.3328 cents. Okay? So let's do that. So it's 0 plus 0.3, and my memory's just gone, 3328 times what? Times the amount of electricity consumed. And the examiner's saying, I want you to call that in. So let's call it in. Easy, isn't it? Okay? When you first look at it, you think, sure, this is kind of tough. But as we worked our way through it, it's actually quite simple. 1 Rand 46 for 31 days, plus 33.28 cents for every unit of electricity. Just remembering, the 33.28, we had to change to rands. Why? Because the examiner said so. And we're here to please the examiner, right? Well, you are anyway. I'm here to please my wife. But you are here to please the examiner. Now, domestic rate 2, P equals, we don't have this 1 Rand 46. All we've got to pay is this amount here, 45,99. And remember, we're not using cents. So we're going to change that straight away to 0,4599. So let's do that. 0,4599 times what? N. Why N? Because that's the amount of electricity I use. So already now I've got two different equations. The one equation I'm going to use if I want to work out how much electricity for rate number 1, or the cost for using a certain amount of electricity for rate 1. And the second equation is telling me how much I'm going to pay if I use rate number 2. Now, let's have a look at the next question. I can almost tell you what the next question is without even looking at it. I bet the next question is going to say this. When are those two going to be equal? In other words, how much electricity do I need to use if my rate number 1 is going to equal my rate number 2? Shall we see if I'm right? Let's do that. Let's look at the question. Here's the question. There is one value for the number of units consumed per month where you will pay the same whether you are charged using domestic rate 1 or domestic rate 2. Use your two equations to work out which number of units per month this is. Now what I'm going to do is I'm just going to go back to the previous page because I'm not going to write down all those units again. Why? Because I'm lazy. So let's just have a look at this quickly. So here are my two equations. Now I'm going to use those two equations and I want to know this. When is the first price going to equal the second price? Okay? Well, what is that first price? The first price was this whole equation here. 1,46, so let's write it. 1,46 times 31 plus 0 rands 33,28 cents times N. And when is that equal to the other price I paid? And the other price was this part over here, which is 0,4599 times N. Now we've got two equations equal to each other. Now I want to stop for a minute and I want to bring the following to your attention. A good examiner would not say use the equations to determine how much electricity you can use for the two prices to be the same. A good examiner would just say to you, how much electricity do you need for the two costs to be the same? You know why? Because there are a number of ways of doing this. And one of the ways is just to play around with figures. So in other words, you're just using a trial method. Okay? Where you're just saying, let's try so many units. Doesn't work. Let's try so many units. That doesn't work. If we try 400 units, oh, that's a bit high. Let's try 300 units. Oh, that's a bit low. So it must be between 400 and 300. So you just play around with figures. And you know, if you approach this question in that way, nobody can fault you on it because you are coming to the right answer. But it could take quite a while for you to start guessing the right answer and working your way through it. So what we say is this. There's a quicker way. I wouldn't say easier, but a quicker way. We've got one equation. We've got another equation. Let's make them equal to each other. And then we're able to work out how many units we can use. So let's have a look at it. Here we have our equation. I'm going to make this very, very simple. First thing I'm going to do is I'm going to change this whole mess here. And I'm going to make it one number. So we are going to take out our calculator again and we're going to say, right, 1.46, multiply that by 31, and I'm going to get an answer there of 45,26. So I'm changing this straight away to 45,26, and we'll leave it in rands. Okay? Plus, I'm going to make this 0,3328n. I'm going to leave out the time sign. Okay? Because whether there's a times sign there or not, if I've got a letter next to a number, we can presume that that means times. So, for example, when you used to do that horrible subject called mathematics, and we're doing maths lit, and it's more reliable subject. We're dealing with everyday stuff. Maths is all kind of weird stuff. You deal with X's and Y's and Z's, and it makes no sense. I mean, who walks into a supermarket and buys an X and a Y and a Z? That's a load of trash, okay? But in those bad old days when you did mathematics, you came across something called 2x, or 3x, or 4x. And your maths teacher, if they were good, would have said that 2x is the same thing as saying 2 times x. Or 3 times x. So 2x means 2 times x. So if we look here, this R, rands, 0.3328n means 0.3328 times n. Okay? In the same way, we're going to rewrite this to being 0.4599n. Right, so our equation's starting to look a little bit more friendly. Now, bad days, you used to do mathematics. What would your teacher say to you? Take all your n's to one side and all your numbers to the other side. And that's what we're going to do here. So we're going to say, right, I've got 0.4599n. I'm taking my other n, this whole thing here, let's take it across there. And I'm going to say minus 0.3328n. Okay, and this side I'm left with 45.26. Now, do you notice that it was plus 0.3328n? When it went across that side, it became minus. Okay, and I have a little story that helps you remember this. Okay, what we do with the signs when we cross the equal sign. I always tell my guys this, and they love the story, and it always helps them remember. So let's scroll down here, and I'm going away from the question because this is an important lesson here. Let's pretend that we've got North America over here. Now, my artistic ability is somewhat shabby, but we'll pretend that's North America, and we'll pretend this little bit over here is Orlando. And you know in Orlando, there's a wonderful theme park called Disney World, okay? So here's Disney World over there. And over here now we have South Africa. And again, South Africa are gone slightly skew and wrong, but we'll pretend it's there anyway. And we're living in Johannesburg, but let's pretend we're in Cape Town, okay? So we're here in Cape Town, and we decide we want to go to Disney World. But there's one problem. We've got to cross the sea. And we have added problems. Our next problem is this. We don't like flying. Because when you're up in the air, funny things happen up there. You've got no control. Okay? The second thing is we don't like to go by ship or by boat. Why? Because we get seasick. Now, there are only 2 ways to get from South Africa across to America, and that's either by plane or by ship. And both those don't suit us. So we go to the South African National Roads Department and we say, Luister meneer, we want to go to America. We need you, please, to build us a bridge. And the guy says, pal, for you, no problem. So they build a bridge. So let's build ourselves a little bridge here. And here's our bridge. Okay? So to get from South Africa to America, we've got a third way, and that's by means of a bridge. Here's my one problem, though. When I drive in South Africa, okay, as a male driver, I will stick to the left-hand side. Female driver, well, that doesn't work. But anyway, let's be serious here. A male driver, we're sticking to the left-hand side of the road. Okay? So here I am driving along, and I'm sticking on the left-hand side. What do the Americans do? They're kind of mixed up people, aren't they? And they drive on the right-hand side of the road. So here I am in America, and I'm driving on the right-hand side of the road. Now, folk, we can see that there's a problem that's going to happen over here. And the problem is this, that as a male driver, when I see an oncoming car, I'm going to panic. My wife doesn't. She does this every day, so she's used to this experience. But for me, I see an oncoming car and I panic. This is not normal, folk. So I go to the National Roads Department and I say, Luister meneer, we got another problem. We need a bridge on the bridge. And so they build a bridge on the bridge. So I travel along, and let's get a different color now because all funny things are happening here. So I drive along, cross over the bridge, and I'm happy. This side, I drive along on the right-hand side until I get halfway, then I'm on the left-hand side like a good South African. So there's no head-on collision. Now, when we're dealing with equations, we have a bridge, and our bridge is like an equal sign. So if I were to draw this equal sign, here it is. Okay? Now a plus, when it crosses my equal sign, it's got to change on the other side. Okay? So the plus becomes a minus. A minus becomes a plus. A times is going to become a what? Divide, absolutely. And a divide is going to become a times. Here's something that's going to make you think. What's a square root going to become? It's going to become a squared. And a squared is going to become a square root. So whenever we change over an equal sign, we know our signs are going to change. Let's go back to our original problem. Gee, I nearly forgot we had a problem. Let's have a look at it. Do you remember this plus? We're crossing over our little bridge. We're going across to America or South Africa. Our plus becomes a minus. So there it is, straightforward. Okay? So plus became a minus. We got our ends on one side and our numbers on the other side. Now, let's slap that into our calculator. And we've got 0.4599 minus 0.3328. 0.3328 equals, and there's our answer, 0.1271. So 0.1271 n. Okay, so we had so many ends, we took so many ends away, and we were left with 0.1271 ends, and that is still equal to 45 Rand 26 cents. Happy? Now, all I'm going to do quickly is I'm just going to obliterate America, get rid of our bridge, and there goes South Africa as well. Okay, now let's carry on. Now I have so many ends and so many rands. I want n by itself. What's the sign between the n and my rands? It is multiply. What do I do when I cross that bridge? I now divide. So we've got 45 Rand 26. We're going to now divide it by 0.1271. The n is staying where it is. Let's take out our calculator again. So we've got 45.26 divided by 0.1271 equals, and there's our answer there, 356.09. Now, I'm not sure if this question asked us how many decimal places, did it? Let's just go back to what that question was. It said, use your equation to work out which number of units per month this is. Guys, it doesn't tell us how many units we got around to, and because it doesn't, I'm going to presume I've got to use 2 decimal places. Why? Because in the front of the cover of my exam paper, it will say, where necessary, round off to 2 decimal places. So that's what I'm going to do here. And my question or answer on my calculator was 356. So let's do that quickly. 356, what? Let's have a look at it. 0.97. That 7 is going to move the 9 up 1. The 9 becomes 10. So I'm going to say then I've got 356.10 units. What's my answer telling me? My answer is saying this, that if I use 356.10 units, and I use the pace scale number 1, okay, so the rate 1, or I use rate 2, no matter what rate I use, if I use exactly 356.10 units, I'm going to pay the same, okay? And how much am I going to pay? Well, let's work that out. Now, this question's not asked, but I'm going to ask it anyway. How much will that bill be? Well, let's have a look at it. So we know now that, well, I've done something wrong here. Here we go. Okay. We know now that I'm using 356,10 units. How much does every unit cost me? Well, if I use unit 2, it's going to cost me that amount of rands. 0.4599. 0.4599. Okay? Let's do that on our calculator. So we got 356.10, multiplying that by 0.4599, and we're going to land up then with an answer of 163 Rand 77. Okay, so it's 163 Rand 77. Let's just confirm that it is indeed. Okay, so that's how much it will cost me if I use rate number 1. If I used rate 2, would it also cost me that amount? Well, it should, shouldn't it? Because we just said if I use that amount of units, I should get the same answer. So let's try and figure it out. Let's try and prove that we are doing the right thing. So I'm going to say, right, we use 356,1 unit. We multiply every one by, what was rate number 1? Rate 1 said 0.3328. 0.3328. Oops, let's get rid of that. Okay. But there was another charge. Do you remember what that other charge was? That other charge was for every day we use electricity, they're going to nail us with 1 Rand 46. So it was a further 1 Rand 46 times, and the examiner put us at ease and said times 31. Okay, I'm just going to confirm that because I'm getting old and I forget a lot of things. Yep, 1 Rand 46. Okay, so if we work that out on our calculator, we should, and I'm crossing my fingers here, we should get the same answer. Okay, if we don't get the same answer, we're taking an ad break. So let's have a look here. So we've got, clear our calculator, 356.1 multiplied by 0.33 and what was it? 28 equals, and I get 118 Rand 51. 118 Rand 51 plus, what is this over here? We've got 1 Rand 46 times 31 equals, and we land up with 45 Rand 26. So plus 45 Rand 26. Now, this is where we hold thumbs and really hope it works out to the same. Let's add those up together. 45.26 plus 118 Rand 0.51 equals. Now, before I push equals, let me tell you this, because I might have to excuse a mistake I make here. Sometimes it won't work out exactly to the cent. And the reason for that is sometimes during our calculation we've had to round off. Okay? So we round off a bit here, we round off a bit here, and so doing we lose a cent or two. But the examiner is aware of that. Again, because they're lovely people, they understand these things happen. But we should get very close, if not identical. Let's look. I'm going to push the equals. Here we go. And 163 Rand 77. Folk, we have a winner. Okay? 163 Rand 77 cents to the exact cent. That's just phenomenal. I love it when things work out like that. And I love it because, first of all, it means I haven't made a mistake. But second of all, because maths lit is real life. It works, folk. It's got to work. Okay. That is now the end of our question number 1. We'll start question 2. You ready for it? Here it is, question 2. A windmill used for pumping water from the underground consists of the circular windmill mounted to a tower as shown in the scale drawing below. The tower is constructed using 4 main poles that lean inwards and meet at the point that is the center of the windmill. The height of the tower, excluding the blades, is 9 meters. The length of the windmill blade is 1,5 meters, and the tail has to be 50% longer than the longest blade. The dam is 0,4 meters away from the structure. Now, do you remember earlier on, I said sometimes we'll read a question and we will say, oh my giddy aunt, what do we do? And this is one of those questions where it's just loaded with so much information that we don't even know where to start. Now, this examiner was very nice to us. What he actually did was he gave us a diagram. Let's have a look at it. Okay? So he's actually said, here's a diagram. And this diagram helps explain all that jargon that we just read. Now, guys, if you get a question like this in an exam, don't feel shy to take your exam paper and write all over it. I'll show you what I mean. This is what I'm going to do. Here's my picture, and I'm going to say, right, I have a windmill. It has 4 posts. Great. We told that the height of the tower, excluding the blades, is 9 meters. So I know my height up to my windmill. There's my windmill starting. From there, all the way down to the ground, I have a height of what? Of 9 meters. Okay? I'm also told that each blade is 1,5 meters. So one blade from, and I'm going to take a different color here, from the center to the end of the blade, I've got 1,5 meters. What is that length in pink? From the center to the outside circle. We know it as the radius, don't we? So the radius of that whole circle, that windmill circle, is 1,5 meters. That means my diameter from one end of the blade through the center to the end of the other blade must be 3 meters. And they actually help us here with the diagram. They tell us that. They're saying, wait, from this part all the way to that part, we're dealing with 3 meters. Now, guys, now that I have this all drawn on my diagram, my question is going to make more sense. I've got a whole lot of figures here, and now I don't have to read that long, horrible paragraph. I can just look at the diagram and extract all the information I need from it. Let's see how much easier this is going to make it. So my question, what is the circle area that is covered by the windmill when it's turning? So we have this huge windmill, and it's just turning and turning and turning. What area does the actual windmill, the windmills itself, take up? Okay? So we are going to say, right, my question gives me a formula. And if I don't use the formula that the examiner has given me, I've made a mistake. Right? I say this time and time and time again. And if you've seen our previous programs, you would have heard me say, no examiner wakes up in the middle of the night and says, how can I confuse my students? Let's just throw in some arbitrary, funny little formula. That does not happen. It never will happen. If they give you a formula, you're going to use it. If you don't use it, you're wrong. So, area, pi r squared. So I'm going to write that up here next to my diagram. Area equals pi times r squared. And it goes on to say, no it doesn't, but it should. It should tell us pi is equal to 3,14. Okay? All your exams, even in matric, pi will always equal 3,14. It's the accepted thing nowadays, and it's got to be done. Okay? In the good old days, you would take your calculator. If I can bring up my calculator here, you will see you would take your calculator and you would actually find pi on that calculator. And there it is there. So for this calculator, I'd push shift pi. Okay? However, not everybody has a calculator like this. Some folk just have a simple basic calculator. And you know what? Besides that, in real life, when you're walking through a shop, you don't suddenly whip out your huge, humongous calculator and start pushing all kinds of weird and wonderful buttons. Normally, you'd whip out your little cell phone and you would just push little buttons on that cell phone if you were wanting to calculate certain costs of things. And maths, it's all about real life. So we're going to pretend we've just got a basic little calculator, which you could find on your cell phone. So we're going to say pi is not this humongous 3,1425 da. We're just going to say, you know what, let's call it 3.14. Okay? So pi is equal to 3.14. So going back to our question now, area, and remember what area we're finding? We're finding the area of this part over here. Okay? So it's 3,14 multiplied by the radius of that circle. What is the radius? Well, the examiner helped us and said the diameter was 3. He also helped us by saying that the length of each blade was 1,5 meters. So he's told us two things. The diameter 3 meters, the length of a blade 1,5. So what he's actually telling us is, hey, the radius is 1,5 meters, pal. So that's what we're going to do. 1,5 meters. Now, again, I'm going to bring something important to your attention. Okay? If you look here at the screen, you can see I've written 1,5. So many students in their final matric paper would say, gee, this is easy. Getting my calculator, pushing 3.14 times 1,5. Guys, let's look at this. It's radius squared. So it's 1,5 squared. So let's do that now on our calculator. I'm going to say I have 1.5 squared multiplied by 3.14 equals, and my answer is 7,065. So I'm going to say equals 7,065 meters squared. Why squared? Because we're dealing with area. Remember, perimeter, just the unit. Area, unit squared. So we're dealing with meters, but because it's area, it's meters squared. Now, I just want to look at the question here and find out if they ask us how many decimal places. No, they haven't asked us how many decimal places. So what am I going to do? I'm going to open my exam paper to the very front page. And I'm going to read the instructions. And guys, the instructions will probably say, where necessary, round off to 2 decimal places. This is necessary. So let's look at our answer. Our answer is 7,065 meters squared. We want 2 decimal places. We're going to say it's 7,0. That 5 is going to change the 6. 7,07 meters squared. So that's the area taken up by this entire actual windmill. Okay, let's move on. Next question. How far is the top of the windmill from the ground? Now, remember we said this distance from the center of our windmill to the ground was 9 meters. How far is this little distance here to the top of the windmill? Well, it's the length of one blade. And the length of one blade we know is 1,5 meters. So we've got a little 1,5 meters there. So what's that whole length? Hey, guys, this is straightforward. In fact, let's have a look. It's only worth 2 marks. I'm not going to use very much mental power here. All I'm going to say is 9 plus 1,5, and I'm going to get 10,5 meters. Not meters squared? No, we're not working out area. Not meters cubed? No, we're not working out volume. Just meters, because we're just calculating a length. Okay? Let's move on. This is so basic, life's getting enjoyable. Now, a cube with side length of 10 centimeters can contain exactly 1 liter of water. What volume in cubic meters does 1 kiloliter of water occupy? Now we're coming to the real stuff. Okay? So they're saying, if I give you a cube, what's a cube? A cube is a little square box, with the length and the breadth the same, and the height the same. So if I were to draw one, and again use my artistic ability here, we've got a little square box, and there it is. Okay? And this is saying that if I put 10 centimeters in depth, 10 centimeters high, and 10 centimeters long, I could actually put a whole liter of water into that container. Now, guys, 10 centimeters is not very long. It's about that long. So if I got a box 10 centimeters, 10 centimeters, and 10 centimeters high, I could fill a whole liter in there. Now, that's something I do with my class, and I encourage you to do that. At the end of this program, get a piece of paper and make a box 10 centimeters wide, 10 centimeters long, and 10 centimeters high. Make a box, put a lot of sellotape around it, and then go to the kitchen, get a 1 liter jug, and pour all the water from a whole liter into that little box, and it fits perfectly. Promise you, it's true. I know it does. Okay? We do it every year with my classes. So one little 10, 10, 10 contains a liter. So I can fit a whole liter into that box. Well, we've learned nothing new because examiners just told us that. Let's get to the question. What volume in cubic meters? Now I have a problem. My problem is this, that the examiner's been talking about centimeters, and now the boykie goes and starts changing the whole dynamics of this question. And he now starts talking in meters. So straight away, I'm going to say to myself, change those centimeters to meters. And that's what I'm going to do. So I'm going to say, right, I'm going to work out now, I know 10 centimeters is how many meters? Okay, there are 100 centimeters in a meter. So I've got 0.1 meters, 0.1 meters, and 0.1 meters. Now a box of 0.1 times 0.1 times 0.1 will give me a liter. Let's have a look at that. Okay, so my volume, 0.1 meters, times 0.1 meters times 0.1 meters equals. Now I'm going to use the calculator because we're going to land up with a whole lot of 0, somethings. And when you got 0.1 times a 0.1 times a 0.1, we get so dear Makara, it's quite scary. So what we do is we use a calculator, and I say this every time I talk to you on TV. Guys, you have a calculator. Your folks paid a lot of money for it, so use it. Okay? Be lazy. I give you permission. Use the calculator. It's a wonderful tool. Let's do it. So I'm going to say, right, I've got 0.1 multiplied by 0.1 multiplied by 0.1 equals. And there I get my answer of 0.001. So I've got 0.001. What? Meters cubed. Why cubed? Because we're dealing with a cubic box and we're dealing with volume. And volume is meters cubed or centimeters cubed. In this case, meters cubed, because our units were given in meters. So we know that that is equal to 1 liter. But the question says, how many cubic meters does 1 kiloliter of water occupy? How many kiloliters, or how many liters in a kiloliter? Okay. If I said I've got meters, how many kilometers in a meter? Or how many meters in a kilometer? There are 1,000. Okay? So as soon as I have kilo, I know I'm dealing with the number 1,000. So I know 1 liter times 1,000 liters will give me 1 kiloliter. Okay? Or just times 1,000. So I've got 1 kiloliter. Now, how did I get 1 liter to a kiloliter? I multiply it by 1,000. Now, what I do on one side, I've got to do on the other side. Okay? Imagine you've got a little brother or a little sister at home. And you get home one day and your parents say to you, we got some good news. The good news is we're giving your sister an extra 100 Rand a month pocket money. And you get excited now, eh? And you say, yes, yes, yes. And they say, no, that's all. We just wanted to let you know. Well, that's just not fair, is it? I mean, the disappointment would just shatter you completely. Because your sister's getting extra money, you would expect you also getting extra pocket money. What's good for one is good for the other. So on the one side of my equation, I've multiplied by 1,000. It only stands to reason then, because we're fair and wonderful people, that on the other side, we're also multiplying by 1,000. So that's what I'm going to do here. I'm going to say, all right, I've got 0.001 meters cubed. Let's multiply it by 1,000. And that's what we're going to do. I've already got 0.001 on my screen, timesing by 1,000, and I'm going to get an answer of 1. So I know that 1, when I get a pen, here it is, 1 cubic meter is equal to 1 kiloliter of water. In other words, if I got a box and I made a huge box, now you can't do this at home because you need a lot of paper and your mom will get upset with you. But if you were possible and you went to the woodwork department at your school and you said, make me a box 1 meter by 1 meter by 1 meter high, okay, and they made this box for you, you could fit in 1,000 liters of water into that box. So 1 meter cubed is 1 kiloliter of water. Sure. So eventually we've got to our answer. So eventually we can move on, and let's do that. So our next question says this. A farmer digs a borehole and installs a windmill to pump out the water. He needs to build a circular dam to store this water. This dam is in the form of a cylinder that has a diameter of 12 meters. If the dam must be able to contain at least 180 kiloliters of water, how high should the walls of the dam be all around? Okay, so let's have a look at this. They also tell us this, that volume of a cylinder is equal to pi times r squared times h. So we know we are going to use that formula. We're going to use it because the examiner gave it to us and he's a nice guy. And if he gives us a formula, use it. So let's do that. And looking at my dam now, what's the question say? It says this, that it has a diameter of 12 meters. So from one end of the dam to the other end of the dam is 12 meters. That means straight away I know my radius must be 6 meters. Okay? Can you see how just from being given one bit of information, I'm giving myself more? Okay? I'm told as well that the dam must contain at least, so we've got to put in here at least 180 kiloliters of water. Okay? What's 180 kiloliters? It's 180,000 liters. How high should the walls of the dam be? Okay, so we're going to say we've got to use this formula. Volume of a cylinder is equal to pi times r squared times h. So let's work it. We're going to say, right, volume equals pi times r squared times h. My pi I'm going to use 3,14. What's the radius of my dam? The radius of my dam is 6 meters. So let's slap that in there straight away. 6 meters squared times the height of my dam. What's the height of my dam? Hey, that's the question. So we're going to say that's what we got to work out. So for now, I'm going to call the height h. Why? Because h stands for height. Okay, so h it is. Now, what is the volume of this actual dam? It's going to be 180 kiloliters. Okay, there it is. So now we can work out the actual volume of our dam. So in doing that, I've got 180 kiloliters is equal to 3,14 multiplied by 6 squared, we know is 36 multiplied by my height. I've got 180 is equal to, let's multiply those through together, 3.14 multiplied by 36, and I get an answer of 113,04. So it's 113,04 meters squared times h. I'm trying to find out h. Now, what signs between the h and this whole huge number? Times. When that number goes across, what am I going to do? I'm going to divide. So I've got 180 divided now by 113,04. Okay, my height is therefore going to equal, let's do it together, clear our calculator, 180 divided by 113.04, and I'm going to land up then with an answer of 1,599, and it says 2, I'm going to leave it as that then, 1,59 meters. And that is the height of this little dam over here, 1,59 meters. Okay, so again, folk, when we looked at the question as a whole, it was kind of scary. However, when we used this diagram and we wrote a whole lot of things on our diagram, somehow life was made a lot easier for us. So do that, hey? And I always say to my students, at the end of the exam, if you come out of an exam with a totally clear question paper, then something's wrong. Because you should have scribbles all over that question paper saying this is this and that's that, and trying to just explain the question in a diagram format. However, don't ever do any working on your question paper. Because if you do working on your question paper, what actually happens is you leave the exam room, you take your question paper with you, and all you do is you hand in your script. You don't hand in your question paper. So how am I going to mark what you've written on your question paper? It makes no sense. And I get so mad with guys in my class who do that. They take their question paper, do all the working there, write the final answer on their exam script, hand the exam script in, and they get naught because they've made a mistake. But they've done all the working on another piece of paper or on the question paper that I don't see. So I can't even give them part marks for that. Okay? So the question paper, draw, scribble, but don't do any working. Do that in your exam script so that your teacher can mark it. Right, let's go on to the next question. And the next question says this. If the dam is only 80% full, how many liters of water does it contain? Now, guys, our dam could contain 180,000 kiloliters, or 180 kiloliters. Is that right? Let's just see. Yeah, 180 kiloliters. So we've got 180 kiloliters. Okay. And we only want to fill it 80%. Now remember, 80% is always 80 over 100. 60%, 60 over 100. 40%, 40 over 100. You get the idea. It's always over 100 because percentage is out of 100. So we want to take 180 kiloliters and find 80% of that. But I'm going to stop you for a minute and say this. Let's read the question. If you got this question and it said, how many kiloliters, how full is the dam in kiloliters? If it's 80% full, you would probably get 2 marks for that. But this question is for 3 marks. So there's a little trick here. Let's read it again. If the dam is 80% full, how many? Here's the trick. Liters. So let's get rid of these kiloliters and change them to liters, shall we? How do we do that? We're going to multiply by 1,000. So we times by 1,000 and we get 180,000 liters, and we're going to find 80% of that 180,000. So again, we're saying 180,000, 1, 2, 3, multiplied by 80% equals, and there we get it, 144,000. Okay, so it's equal to 144,000 liters. So I had this huge dam. It could take 180,000 liters. It's not entirely full. It's only 80% full, so it can only take 144,000 liters. Are we clear on that? And that brings us to the end of this question. Ready for the next one? Question 3, here it is. Mukala is busy building his new house. The length of the house is 11 meters and the width is 6,10 meters. The building is a double story. The details below are found in his notebook. Okay, so here we have a guy called Makala, and he wants to build this house. And it's not just a single-story house, but it's a double-story. This Makala is quite a Lani guy, okay? Doesn't just want one story, he wants two of them. And what he's looking at now is he comes across a table, and this table is shown here, where it shows the labor cost for every part of the building. So for doing the foundation is going to cost him 5,500 Rand. For building of the walls below the top floor, 7,000. For plastering the walls inside and outside, 6,000. Preparing for throwing the concrete on the top floor, 4,500. You get the idea. Okay, so there are a whole lot of costs involved with building this house. And in fact, it's not the cost of the actual materials, but according to this question, it's the labor cost. In other words, it's the cost, the labor, here it is, it's what he's going to pay somebody to do that work. Added to that price, of course, is the cost of the bricks and the concrete and everything else. But the question at this stage, we're just looking at the labor costs. Okay, so we've got an idea of the question. Let's tackle it. The first part says, express the cost of the most expensive stage of the work as a percentage of the total labor cost. So there are two things we've got to find here. First, we've got to find the most expensive, and second of all, the total labor cost. So what is the most expensive? Well, looking at this, we've got 5, 5, 7, 6, 4, 5. Oh, here's a big one, 18,000. We got 14,000. That's just a big, but not as big as 18,000. And I would say 18,000 is our biggest cost. So we are going to say, right, we've got 18,000 Rand, and we want to express it as a percentage of the total cost. So I know I'm going to multiply something over something by 100, because that's how we work out percentage, isn't it? It's going to be that cost over the total times 100, with percentage always times 100. So what is this bottom figure? Well, it's the total labor cost. In other words, we've got to say 5, 5 plus 7 plus 6 plus 4, 5 plus 18,000 plus that, plus that, plus that, plus that, plus that. You're going to stop, you're going to think for a minute and say, what is it, what is it, what is it? Ah, it's 83,100 Rand. How did I get that? I actually cheated. I did it before this, okay? But what you would have to do is you'd have to sit with your calculator and actually say 5500 plus 7,000 plus 6,000, and you come to that final figure. Okay, and that final figure we said was going to be 83,100 Rand. Now, we got 18,000 over the 83 times 100, and this is again where we're going to use our calculator, and we're going to say, right, we have 18,000 over 83,100 times 100. Okay, now I want to show you this calculator quickly. What I used here was I used the fraction button. Now, if your calculator doesn't have this fraction button over there, that's okay, all right? What you could then do is you could say 18,000 divided by 83,100 times 100, because 18 over 83,100 actually means 18,000 divided by. Are we clear on that? Okay, equals. And here's our answer. It's 21.66%. So I've got 21.66%. Okay? And it doesn't tell us whether it wants it as 1 or 2 or 3 decimal places. We're going to presume then, we're going to look at our front cover and see what it says, and it'll probably say around to 2 decimal places, and that's exactly what I'm going to do. Next part of the question says, the length of the top floor is 11 meters. The width, including the balcony, is 7.60 meters, and the thickness is 17 centimeters. Calculate the volume of the concrete used for the top floor. And then it goes on and it gives us an equation. We got an equation. What do we do with it? We use it. Why? Because we got it. And the examiner's not going to give it to us unless we need it. So I know straight away volume equals length times the width times the height. Now we're just going to slap a few things in here, all right? We know the length is 11 meters. We know the width is 7,6 meters or 60 meters. And the height of that concrete slab is a tiny little 17 centimeters. Okay, so we're going to say 17 centimeters. Now, I'm going to stop for a minute, and again we're going to look at this over here. 4 marks. Guys, the fact that that's worth 4 marks tells me there's a little trick. Because there's no way we're just going to slap in figures, use our calculator and get 4 marks. There's a trick here. So let's see what we've done. If you look at our figures, you can actually see, and I'm going to do it in pink, that here I've got meters, here I've got meters, and here I've got centimeters. And that's a big no-no when we calculate volume or area or even perimeter. You cannot have different units. You've got to have the same unit. Okay? You just got to do it. It's one of the laws that you've got to apply. Meters, meters, here I got a problem, centimeters, I'm going to change it to meters. How am I going to change it to meters? Well, we know there are 100 centimeters in a meter. So I'm going to divide that by 100. So I've now got 11 meters times 7,60 meters times 0,17 meters. Okay? Now our calculator comes to play, and we're going to say, right, 0.17 multiplied by 7.6 multiplied by 11, and I'm going to land up then with an answer of 14,212. So I've got here 14,212 meters cubed. Why cubed? Because we're dealing with volume. Again, folk, the question doesn't say how many decimal places, so I'm going to presume that the front cover of your exam question paper will say round to 2 decimal places where necessary. Let's do it. So I've got here 14,2. So the 2 doesn't have an effect on the 1, so our answer is going to be 14,21 meters and cubed. Why cubed? Because we're dealing with volume. All right. Straightforward, simple. We had a slight little trick where our centimeters, we had to change that to meters. But other than that, it was a pretty straightforward question. Okay, let's move on. There's another part to this question. The next part says, a cubic meter of concrete cost 850 Rand. How much did Makala pay for the concrete for the top floor? Okay, so Makala, let's see what it is. It's costing us 850 Rand. And how many cubic meters is he buying? From our previous question, we worked out he was buying 14,21 meters cubed. Now, I want to stop there for a minute and say the following. Imagine you walk into a shop and you are really in the mood for a chocolate. I mean, it's just to die for. You haven't had a chocolate for months and you're just thinking, gotta have this chocolate. But part of you feels guilty because you're on a diet, like I am, as you can see, okay? No sniggers. So you want this bar of chocolate, but you can't have the whole thing. Now, guys, even if you don't want the whole chocolate, you've got to buy the whole thing. I can't walk into a shop and say, here's a chocolate, sorry, don't want the whole thing, snap it in half, put the other half on the shelf and eat the other part, okay? You're going to have a very angry shopkeeper. You're going to have some very angry people with you, especially the next customer that comes along and sees half a chocolate, okay? And if the next customer is my wife, she will get extremely annoyed with half a chocolate. She eats chocolate like it's going out of fashion, okay? And there's no way she wants to come behind another customer and buy half a chocolate. The shop manager is not going to want to sell you half a chocolate. And in the same way, what we've actually discovered here is that we need 14,21 cubic meters of concrete, right? But they sell the concrete in cubic meters. So I have one of 2 options here. I either say, I'll buy 14 cubic meters, or I'll buy 15. Now, if I buy 14, I'm going to be slightly short. And there's nothing worse than walking on the top floor of a building and there's a huge hole in the floor and you can see what the people downstairs are doing. And that's exactly what's going to happen if I only buy 14 cubic meters. I'm going to be short of 0.21 cubic meters. So I have to buy 15. So let's go back to our question. We're going to have to buy 15. So here's the cost. How many am I buying? I'm buying 15 cubic meters. We take our calculator and we say, right, we've got 850 Rand that we're paying for 1 cubic meter. I want 15 of these guys, so it's actually going to cost me, and here it is, let's read the answer before I get rid of it, 12,750 Rand. So 12,750 Rand is what I'm paying for that concrete. Happy? Easy, but a slight little trick, okay? Can't buy part of something. You've got to buy it as a whole. So we couldn't buy 14.21. We had to buy 15 cubic meters because they sell them in cubic meters and each one costs 850 Rand. Okay, next part of this question. If the maximum load of concrete that the lorry can carry is 6 cubic meters, how many loads of concrete were delivered to pour the top floor? Explain your answer. Okay. Now, this explain your answer, oh my goodness, that opens up quite a can of worms here, because do I explain in English or do I explain mathematically? Now, I would probably accept both answers, but then I'm a nice guy. I don't know what your teacher would do, but hopefully they do exactly the same thing. So how many cubic meters did I need? I needed 15. So if we look here, I've got 15 cubic meters, but my truck can only take 6 cubic meters. In other words, I'm saying, how many times will 6 cubic meters go into 15? Now we're going to get a funny little answer here. And we are going to say this. I've got 15, I'm going to divide it by 6, and what happens? I land up with 2.5. 2.5 what? 2.5 truckloads or lorry loads. What do they call it? A lorry. Okay, so 2.5 lorry loads. In other words, I'm going to have to say to the driver, go get cement, please. And he's going to go and he's going to come back. And I'm going to say, go get cement, please. And he's going to go and he's going to come back. And I'm going to say, go get cement, please. But this time, I don't need a whole truckload, only half a truckload. But he's still got to go and get some more. So how many trips is he going to do? He's going to do 3 trips. One for a whole load, one for a whole, another one for a whole load, and one load for only half a load. But he's still got to do that 3rd trip. So how many trips is he going to do? 3 trips. Are we clear on that? Okay. If you wanted to explain your answer in words, I suppose you'd say something along the lines that the first load he can take 6 meters cubed. The second load he can take 6 meters cubed. That means he's taken a total of 12 cubic meters. But he still needs to take 3 cubic meters. So he's still got to go back and do another trip. He's going to do 3 trips, but the 2 are going to be full loads, and the 3rd one is going to be half a load. All right? Let's take it another step forward. Now, the distance on the plan between 2 walls is 27.5 centimeters. And the actual distance between the 2 walls is 11 meters. What is the scale on the plan? All right. Now, for those of you who've never built a house before, and I haven't built a house before, but I'm told that you don't just get out there and say, right, we're going to build, let's go for it. Bring on a brick, bring cement, let's have a party, okay? You've actually got to build to a plan. And a plan is on a piece of paper that's scaled down from what the final real product is going to look like. So earlier on in the series, we looked at scales, we looked at maps. And we said that a scale diagram is exactly the same as the final, or looks the same as the final product, but is a smaller version. And so if we were to look at this question, what we've got now is we've got the distance between two walls on our map is 27,5 centimeters. But the real distance is 11 meters. In other words, I have my map and I have real life. Okay? My map says 27,5 centimeters represents 11 meters. I want to know what scale is used. Now, do you remember earlier I said to you that one of the laws or one of the rules that we just got to learn is that we always work in the same unit. If we look at this question, I have different units here. I have centimeters and I have meters. I've got to get them to the same unit. So I'm going to say 27,5 centimeters is the same as, how many centimeters in a meter? 100. So I'm going to add 2 zeros. So 27,5 centimeters on the map is the same as 1100 centimeters in real life. What is my scale? Now, a scale we normally have 1 is to something. 1 centimeter on the map represents something in real life. Let's have a look. I want to know what is 1. How did I get that 27,5 to 1? I divided it by 27,5. 27,5 divided by 27,5 is 1. And remember another little rule, what you do to your little brother, is this a good for you? They get extra pocket money, you've got to get it too. So on the one side, we divided it by 27,5. On the other, we're also going to divide by 27,5. So this is what we're going to do. We're going to say we've got 1100 divided by 27,5, and our scale is going to be, and let's do that, 1100 divided by 27.5 equals, and we get 40. And that's a lovely scale to work for, or work with. So in other words, 1 unit on our scale map represents 40 units in real life. Now, my guys always ask me this question, 1 what? 1 centimeter or 1 meter? Well, it really doesn't matter. 1 centimeter represents 40 centimeters, or 1 meter represents 40 meters, or 1 kilometer represents 40 kilometers, or even this one, 1 length from my elbow through to this thing. What's this? A wrist. So from my elbow to the wrist, if I were to put that down on a map, that length would represent 40 of those lengths in real life. So the unit's not important. As long as we understand 1 of something on the map represents 40 of something in real life. Got that? Okay. Let's look at our next question. The next question says this. Makala measures the height of the steps in his new house and finds that the height between 2 consecutive steps is the same. The first step is 15 centimeters above the floor. The second step is 30 centimeters above the floor. The third step is 45, and the fifth is 75. What is the height of the 17th step above the floor? Okay, this is for 3 marks. It's not difficult, people. All right? So we've got a whole lot of steps. Here they are. And we're going to just keep climbing up to the heavens. Right? And we got 17 steps. I don't have that many. But anyhow. So my first step from the ground upwards, let's use pink again. So this is a height of 15 centimeters. The second step from the ground is 30. The third from the ground is 45. So, what are we asking ourselves? Okay? We're asking ourselves how high is each step? So if the first one's 50, the second height's 30, the next one's 45, I can see that each step is 15 centimeters high. So now the question is, how high is 17? So the 17th step, if each one is 15 centimeters, well, it's easy, isn't it? All we're going to say is 17 times 15. 15 centimeters. So 17 multiplied by 15 equals 255. So I've got 255 centimeters. Okay, so let's just read the question. We're making sure how above the floor. It doesn't ask us whether it wants in centimeters or meters. I can leave my answer as 255 centimeters above the ground. That was an easy one, wasn't it? And I'm sure you would have got it straight away. Let's read through question 4. Travelers to South Africa come from all over the world. A researcher in the Tourism Office of South Africa is interested in finding out more about the travelers who are from the rest of Africa, as well as those from Europe. She has collected the following information about the number of travelers arriving in South Africa from the rest of Africa and from Europe for each month in the year. Okay, so what's this question about? Simply put, we have a travel agent who's utterly bored. Got nothing to do with her life, and so what she decides to do is count how many people come to South Africa every single month. Not only is she doing that, but she's also deciphering as who comes from Africa and who's coming from Europe, which is the most bizarre thing to do. But nevertheless, this is what she does, and she gets a great kick from this, obviously. So we look at this table in front of us here, and we see exactly all her stats. And here it is. From the rest of Africa, there are 368,000 people who came to South Africa in January. From Europe, there were only 90,000 that came to South Africa. Okay? If we jump to June, in June there were 340,000 people who came from Africa to visit South Africa, whereas from Europe only 44,000 came. Do you get the idea? Straightforward, but my Gideon, there's a whack of information here. Okay? There are so many numbers that it's easy to confuse yourself. I don't like this question. I think the examiner is quite horrible, actually. Okay? Would it be nice if the examiner had actually said she does it for the first 6 months of the year or the last 6 months of the year? But this examiner was probably desperate to find out if his or her students understood a median, mode, a range, and really wanted to test them. Okay? So here's a whole lot of information. Here's the question. For both groups, calculate values for these statistics. Calculate the mean, the median, the mode, and the range. Now, folk, we're almost coming to the end of the session, and because of that, I'm not going to sit here and go through it, right? We're just going to discuss what we would do and how we would go about it, but we're not actually going to sit and go through it, because my goodness, this question isn't a problem, it's a career. We're going to be here forever. So let's just summarize it quickly and go through it. So first of all, calculate the mean. How do we calculate mean? We're going to take all our bits of information, all right? We're going to add them together. So we're going to say 368,000 plus 290,000 plus 332,000 plus, and we're going to divide it. So we're going to have this entire total over here, and we're going to land up dividing it then by the number of data I have, which in this case has to be 12 because there are 12 months in the year. So we add up all these things and away we go. Now I've cheated a bit because I've actually added it all up, and I'm going to say for group A we've got a total here of 4,237,000, okay, and we're going to divide that by 12. So I've taken all those figures, added them together. That's the result I got, 4,237,000, dividing it by 12, and we get an answer of 353,083. So on average, or our mean average, we're saying every month from Africa, we're getting around about 353,000 people walking through our airports or across our borders or through the port in Durban or Cape Town or Port Elizabeth, but generally 353,083 people per month are visiting South Africa from Africa. We would do the same with Europe. We'd add up all those figures and divide by 12. Now, The next thing we're going to find is the mean. So some of my students get mixed up, and this is how I teach them. Median, if I say the word median, it's like saying middle. So when I'm asking you to calculate the median of a group of data, I'm asking you to find the middle one of that group of data. Okay? If I say to you, hey, what's the mode? Now, mode sounds like most. Okay? Mode, most. So let's look at our data, and we're asking, find the median of all this data. In other words, put it in the correct order. So we would say, right, what's our lowest figure? Looking at this, our lowest figure would be 290,000. So I would write 290,000, okay? Then the next figure would be 334,000. And the next, 332,000, missed one there. And the next one would be 334,000, 335,000. 348,000. You'll notice I'm not writing the thousands because I'm being lazy and I'm aware we're running out of time. Okay? The next one would be 351,000. Then 362,000. Another 362,000. Look at that, hey? There are actually three of them. Another 362,000. Then 368,000. Then 372,000. Then 421,000. So we're trying to find the middle of it. Because we're trying to find the middle, let's work from either end and work inwards. So we're going to say, we've got rid of that, we got rid of that, we got rid of that, we got rid of that. One this side, one that side, one this side, one that side, one this side, one that side, and oi, we'll end up with 2 in the middle. Now, that's a bit of a problem, isn't it? We want to find the middle one, and there's no middle one. There's 2 of these characters. So what we got to do is we've got to find the mean of those 2 middle ones. So I'm going to say, right, so we've got 351,000 plus 362,000. How do we find mean? We add up the 2 figures and we're going to divide it by 2. And when we do that, then we're going to land up with an answer of 356,500. Remember? These all had 3 noughts. I was just lazy. I didn't put them in. Okay? So that would then be our median. So our median is 356,500. Now, what is the mode? How do we work out mode? Or how do we remember what the mode is? Mode means most. So what is the most? We said we had quite a lot of 362,000. So my mode is 362,000. Okay? So this was the mode. This was my median. And this was my mean. Right. All 3 are different figures. But they're all averages, hey? Because you get 3 types of averages. You get the mean average, the median average, and the module average, or mode. Right. Here's another question that would be posed to you in a paper 2. Which one of those averages best describes the number of people who enter South Africa from Africa? Okay? So if we looked at this, here are all our figures. There they are. Of all those figures, I have 3. I have this guy, 353, 356, and 362. Okay? Which one best describes that? Well, if we look at all our information, they're all pretty close to each other, aren't they? There's no outlier. I mean, in 1 month, we suddenly didn't just have a drop and suddenly only have 42,000 people coming into the country. Or we didn't have suddenly a huge impact where we suddenly had 14 billion people coming into the country. It's been rather close to each other. Okay? In other words, there's been no outlier. And you'll remember what that term means. Outlier means some bit of information that somehow doesn't gel with all the other bit of information. Right? Because there's no outlier, we know automatically then, or should know, that the mean is the figure that best describes our information. Okay? Or best describes the number of people coming into the country. Folks, sadly, our time's coming to a screeching halt here. We could just carry on and on and on, I suppose. Why? Because Maths Lit's about real life, and real life carries on and on and on and on and on. But unfortunately, that is the end of our time.